to Mariah, are we good? Okay. We are about a week and a half away from the first unit test in AP Calculus. That probably fills you with some strong feelings. Maybe you're really excited. Maybe it makes you want to throw up. I'm not sure, but we have the next 7 days to continue learning new things and see where we go with this. Okay. Where we started the unit, we were looking at limits and all the different ways to work with limits, and for the last week it's been applications. What I want to do is we're going to really start this next leg of your calculus adventure by talking about slope of the tangent line. This is something that you talked a little bit about last year with Mr. S at the end of pre-calculus. I'm excited we are coming up on the end of things you already know about. Okay? I don't want to go so fast that I lose you, but I also know you've had some exposure to this stuff previously. Okay? Here's what you need. You're going to need some markers or colored pens, especially for those of you that are like color coordinated. You want this thing. There are rulers in the supply kit. These are rulers. They are not propellers. They are not samurai swords. They are not ninja blades of death. It's a ruler. Just a ruler. I'll tell you, today is also going to be really heavy with some vocabulary, so just sort of make room in your heart for the vocabulary. I've added some more stuff onto the vocab wall. Somehow, no matter how much I increase the font size, it's not big enough for those of you that sit in the wrong part of the room. But you can always go on over and check it out if you need to, but you probably can't see it from where you are. David, you may not even know that it exists from where you are. I'm working on it. Okay, so here's what I want you to do. I want you to take out your ruler. Oh, so awkward. So awkward. And I would like for you to draw a tangent line at the point x equals 4. We're going to start the conversation there. Can somebody remind me, what does it mean to be a tangent line? Jose remembers what it means to be a tangent line. Ramir remembers what it means to be a tangent line. I say tangent line. Jasmine, what does it mean to be a tangent line?
It only touches the graph at one point.
It.
The line.
The line touches the graph one time. So draw for me, please, a tangent line at x equals 4. Tangent line at x equals 4. Tangent lines touch once. It is important that your line is not going through the curve. Your line is touching the curve. It's always so interesting to see what happens with teenagers and their rulers. So if I take a ruler, I'm over here at x equals 4. Somehow I've lost my marker. Here's x equals 4. Your line needs to be just touching the curve at x equals 4. Yes, that's what I mean by a tangent line. What kind of line?
Tangent.
This is a tangent line. Specifically, we're at x equals 4. The point x equals 4 is what we're going to call the point of tangency. It is the point at which the tangent line touches the curve. So we've already got some new vocab coming in here. We've got tangent lines, and we have point of tangency. All right, so far so good. Now, Sir Isaac Newton, right? You may remember him from physics. Last time we saw him, he was sitting under the apple tree. The apple falls down, bonks him on the head. Boom, we have gravity. That's not quite what happened, but that's the guy. Isaac Newton said, you know what? I'm really interested in slope of tangent, which I'm just going to write as tan. Say it with me. Tan. I want the slope of the tangent line. I want the slope of the tangent line at x equals 4. That vertical bar means at. If I want the slope of the tangent line at x equals 4, there's a problem here. You guys have been finding slopes since 8th grade, maybe? 8th grade, maybe it was 9th grade when you first learned about slope. Somebody remind me, how do you find slope?
Right.
You know, Scrumbier, how do you find slope?
Rise over run.
You find slope by doing rise over run, but the problem is this. If I want the slope of this line, what I need is another point. And this line touches the graph how many times? One time. My goal, I want slope of tangent line, but in order for me to do that, what we're going to do is we're going to pick another point. And I'm going to label that point x comma f of x. I want you to pick this other point anywhere that you'd like, but I want you to connect it so that my line connects this point here with the point of tangent. Okay. I definitely want to go slow enough that you can get a good graph going here. Still a tangent line? No. Oh. Just a little bit wrong. Just a little. Eunice, what do you think? Still a tangent line?
No.
Why not?
It touches the graph 2 times.
Because this line over here is touching the graph twice, right? If the line touches the graph twice, we're not going to call it a tangent line, we're going to call it a secant line. Okay. Finding the slope of a secant line marked here should be a very easy thing for you to do. Because you know you've got this point over here at x equals 4. And the coordinates here I'm just going to label as 4 comma f of 4. And you've got this point over here that I'm just going to label x comma f of x. And you guys have been finding slope forever and ever and ever and ever and ever, right? Slope is rise over run, I heard. Slope is change in y over change in x. Slope is y2 minus y1. If I just said go find the slope of the secant, we would find f of x minus f of 4 over x minus 4. And that's going to be secant. What is that? Secant. David, do you want secant? No. What is it that we are really after here? What I want, Edgar, one more time? I know, you were built for lessons like this, John. Tan. Daddy wants some tan. I want slope of tangent line. But the problem is a tangent line involves just one point. So what you do, what Newton said is, you know what? I'm going to pick another point on the curve. Any other point on the curve, I'm going to find the slope of the secant line, and I'm going to use that to estimate the slope of the tangent line. Big picture, are we okay? Turn to somebody near you, explain to them what's going on. This is where I lost people last time. Take us through the story. So Edgar, what's the goal here? What is it that we're trying to find? I mean, yeah, Edgar, sorry, even though I was looking at Abraham. Edgar, go for it.
The slope of secant in order to estimate.
But what we want is
Tan.
tan. You want tan. But Noemi, what's the problem with finding the slope of tangent line? Why can't you just find it? In order to find the slope of a tangent line, you need 2 points. What's the challenge? If we're going to say this is the slope of a tangent line, the challenge is
There's no second point.
there's no second point. I have 1 point. So the solution, Jennifer, what do we do? What you're going to do is you're going to pick another point. You're going to form a secant line, you okay? And we're going to find the slope of the secant. Now I'm curious, how do we feel about this secant line being used to estimate the slope of the tangent? Like good?
No.
I hope not. This is a horrible estimate. Can somebody make it better? How could you make a better estimate? This is the conversation for us to have. Christian, how would you make the estimate better? I hear you say get the line closer to the tangent. I like that. But the way that we're going to do that is we're not going to really change the line. What we're going to change is the point, that second point. How about if we did that point? And so like draw another line. Okay, I'm doing it because I don't have a ruler big enough. That secant line, I'm going to call that secant line number 2, is closer in slope to the slope of the tangent line.
No.
It's closer in terms of the slope. It is closer. It is a better estimate. But if that's a better estimate, what are we really going to do? Find an even better estimate. Jose, how are you going to find an even better estimate? So move the point closer. Make another secant line. So I'm going to call that like secant line number 3. Secant line number 3 is closer in slope to the slope of the tangent line. Everybody mostly okay? See, right? And you might say, well, coach, that's good. That's a good point. That's close. But guess what? I can get closer. Right? I can get closer. How close can I get?
Pretty close.
Like pretty close? Like
honest.
really close? Prom date close? Inappropriate
yes
close? Close. I'm not even sure what that means, Edgar. To find the slope of the tangent line, here's what I want you to do. You're going to find f of x minus f of 4 over x minus 4. But that's not slope of tangent line. This is secant. The way that I'm going to form slope of tangent line, I'm going to move this point closer and closer and closer. Closer, so close to x equals 4 that you know what?
It touches.
Not that it touches. They are so close, you can't tell the difference between them anymore. That is so, it is limit close. So we've got slope of secant, but if you say let that point get super close to 4, get limit close to 4, that's how you find the slope of tangent line. So the thing I want to make sure you've got in your notes, the slope of the tangent line at x equals 4 is going to be the limit as x approaches 4 of f of x minus f of 4 over x minus 4. You might want to put a great big bar or a bubble or something around that to make it really clear. I will tell you, I care greatly about your being able to come up with that formula on your own. And I want to give you another minute to just talk this out with somebody near you. I want to hear the words come out of your mouth. Like, how do you come up with this? What are we doing? Go for it.
Mr. D, can you come here? Can they still see? Or is it kind of too far? Like, will it look different?
I think it'll be okay. I think it'll be okay. They can zoom in. 4, 6, 9, 13, 14, 21.
Where?
That's it. Okay, David, I just said you want to do it quick. There is not nearly enough productive math conversation going on right now. You okay? Robert.
I know, but for the limit part, you plug in the limit or you solve the equation. Yeah, but then you plug in the limit.
Okay. All right, let's do this. We can put away the rulers. You don't need them anymore. Here's the thing. We are not done. Truly, like Kimberly, we just started. All this isn't the number. This is the process. This is the process that we're going to go through and actually to find the slope of the tangent line. I'm going to want you guys to get some practice with this. But what I really care greatly about is that there is some level of understanding of where this formula is coming from. How are we feeling about where the formula is coming from? Okay? You could like go home tonight and have a great dinner conversation with mom and dad over it. But
we don't have
would
dinner at the
teach
dinner
them.
table.
Okay, so here's the key. Here's the key now. Some of you guys are really good with this and you know exactly what to do. In order for me to find the slope of the tangent line at x equals 4, all I need to do is put it all together. Right? I've got to find the limit as x approaches 4. I need f of x. Do we know what f of x is?
Yes.
Yes.
For this particular problem, we know what f of x is. F of x is negative x squared plus 6x minus 1. It's f of x minus, now I need f of 4. Go find f of 4. Okay, maybe you get it right from the graph, you know that it's 7. I was surprised last class, the hardest thing we seemed to do, and I'm not picking on them, that it was a hot mess figuring out what f of 4 is. You could just plug it in and say it's negative 4 squared plus 6 times 4 minus 1 over x minus 4. Great. Right, that's the setup. And then from here, we're just going to let the math skills flow. I think most of you guys can finish this without me. And if that's you, finish it. Negative x squared plus 6x minus 1 minus, I need to evaluate all the stuff that's inside the parentheses. 4 squared is 16, but it's negative. Plus 24, I think that gets me to 8 minus 1, 7. Anybody surprised that f of 4 is 7? Why not? You can see from the graph, right? If x equals 4, the y value is 7. But if you couldn't tell from the graph, you plug it in. Over x minus 4. Okay, you could do limit as x approaches 4, negative x squared plus 6x minus 8 over x minus 4. The goal here is to evaluate the limit. We are pros when it comes to evaluating limits. What are we going to do?
Plug it in.
Okay, you could try plugging it in. I bet some of you are so good with evaluating limits that you probably already have a sense of it's not going to work. Right, we're going to get 0 over 0. So, right, you can like factor and cancel. You can do your X box. I realize the fact that there's a negative leading coefficient causes some problems for some folks. That's okay. Right, my advice for the folks that are going to get messed up by that negative, factor it out. Right, factor that negative 1 out in front first. So it's x squared minus 6x plus 8. In the bottom, it's x minus 4. We're going to get the limit as x approaches 4 of negative 1. X squared minus 6x plus 8. Trust your instincts here. You guys have been factoring stuff like this since algebra 1. So this is not the thing I want to worry about right now. If you're getting 0 over 0 when you plug in 4, you've got a factor of x minus 4 in the denominator. Most likely, there's a factor of x minus 4 in the denominator as well, in the numerator as well. And so for the folks that just factored it, we're getting x minus 4 times x minus 2. Okay, we're good. So the x minus 4's cancel out. And we take the limit as x approaches 4 of negative 1 times x minus 2. When you plug it in, we get negative 1 times 4 minus 2, negative 2. Okay, that negative 2, what is that? That's the limit, but what is it?
Slope.
This is, I heard it, this is
Slope.
slope. It's the slope of the tangent line. Look at that line. Is anybody surprised? Nope. Is anybody surprised that the slope is negative 2? Daisy, are you surprised by the negative?
No.
Why not?
Because it's
The line is decreasing, right? If the line is decreasing, the slope has to be negative. I don't think, Anthony, I don't think you or anybody else in the room would look at that tangent line and say, oh yeah, clearly negative 2. But what I hope you'd say is, I know that that line has to have a negative slope. Negative what? You're going to have to go through this process. Now here's the thing. I know I keep making a big deal out of the conclusion. So here's what the final bit is going to say. What I want to see written down is this. I know that tan at x equals 4 is negative 2. What that tells me about the line is, what does it tell me about the tangent line? Jasmine.
That is decreasing?
That the tangent line is decreasing. Not only is the tangent line decreasing, the function is decreasing. So what I want to see is this tan at x equals 4 equals negative 2, and that is less than 0. Therefore, f of x is decreasing. Make sure your conclusion is not too strong. Because the slope of the tangent line is negative 2, that means the function is decreasing everywhere. Jennifer, where's it decreasing? At x equals 4. Questions before you guys get some practice? Robert?
So we label our tangent graph the same as our original graph?
Nope. What I'm saying is that f of x is the function is decreasing and the tangent line is decreasing. Good question. Other questions before I give you guys some practice time? Okay. True or false? For this graph, tangent line is always going to be decreasing at all the points.
False.
False. Adriana, why is false?
Because on this side of the graph,
On this side of the graph,
the function of f of x is
the function of f of x is
increasing.
increasing, and so the slope of the tangent line is going to be positive. Okay, true or false? There is at least one point where the tangent line will be horizontal. True. Where? Let's get some answers. Where? Where's that tangent line going to be horizontal? Is it 1? Is it 2? Is it 3? Is it 4? Is it 5? Marvin, where's the tangent line going to be horizontal?
Where it changes from going up to going down.
Ah!
Oh no.
Again! I'm sorry, one more time.
I don't get it.
At x equals 3 because? I heard him say the word
It.
it.
Slope.
Where is the tangent line going to be horizontal?
At x equals 3.
At x equals 3.
Because the slope goes from being positive to negative.
The slope changes from being positive to being negative. I think I like that. I think there's a fancy word that we know for x equals 3.
Vertex.
It's a vertex, right? Because we're talking about a parabola. You can also call it a maximum. Like lots of options happening here. Good? All right, so here's what I want you to do. There is a table where we're going to summarize all of our findings here. And then you're going to get some practice. That was probably the longest part of what we're going to do today. Okay. So filling in the table, I'm going to assign you guys some points. We just did, was it x equals 4?
Yes.
Okay. Coordinates for the point of tangency were 4, 7. Behavior of f of x at this point.
Decreasing.
The graph was decreasing. The slope is negative 2. Now the equation for the tangent line, you guys know how to write equations of lines. There's two ways. You've got slope-intercept form, and then there's the point-slope form. I love point-slope. And for those of you that are like, wait a second, what's point-slope? Hold on, Ron Bear. Y equals mx minus x1 plus y1. That's point-slope. That's the one that I want to see. Okay. And for the equation of the tangent line, I'm a big fan of using L of x. L for like tangent line. Okay. So although Lucio thinks it's L of x for him. So L of x is going to be, take my slope, negative 2, x minus 4 plus 7. Okay. So I've got 1, 2, 3, 4, 5, 6 groups of good-looking teenagers. Here we go. for Jasmine and Rambir, you guys are going to go through this whole process again for x equals -1 and x equals 5. Team Kimberly, x equals 0 and x equals 3. Team David, x equals 1 and x equals 6. Team Christian, x equals 2 and x equals -1. Team Anthony, don't ask me to repeat these, I won't remember. X equals 0 and x equals 5. Team Nora, x equals 2 and x equals 6. Did all the groups get 2? Did all the groups just get 2?
Yeah.
Jasmine and Rambir, you guys get 2?
We got
2,
-1
4,
and
5, 7, 8, 12. Perfect. Okay. So your goal, you have 7 minutes to find the slope of the tangent line, the equation of the tangent line, and the behavior of the graph at each of those 2 points. Strongly recommend that you make sure you get the setup right first, because if you get the setup right, everything's good. You can write anywhere that you need to. 7 minutes. Show me what you can do.
Hey, bro.
We have to do it on the same graph?
Yeah. These are easy. You have to write like that.
Oh,
Like that.
So, what I'm saying is that x equals -1.
So 1, 5.
Is
Oh, yeah.
This is where you're going to draw the tangent line.
Oh, it depends on what the question is.
You don't have to draw all of the lines. All we're really interested in is the slope of the tangent. So if you're able to say, oh, I can kind of get this guy here, and you know how to close it. Okay, so what points did I give you guys? 1 and 6. 1 and 6. Okay. So I think it would be a good idea for you guys might want to say, we're going to do x equals 1, we're going to do x equals 6, and then kind of compare it.
Staying the same. Yeah. Is for 3?
So for okay, it's up here that I like.
So we follow the same equation, right? This would be as x approaches 0 for the first one.
Show me your setup. Love it. Going. And writing annoying little brother, Jonathan. Good, good. Keep going, keep going. Love it.
Wait, we still use this, right?
Love it. Good, keep going. So can I see your setup? I just want to see this first. When is x approaches 0? Good. And we're going to keep writing. Right, that big. Kimberly, can I see what you got?
Wait, which equation are we using?
Love it. Love it.
That's the equation.
What did you get? You're going to say what you are? Good. Good answer. Okay. Jasmine and Rambi, how are we doing?
Limit of x equals -1, f of x minus 11. F of x minus that over that 11.
So then whatever f of 0 is right here, put that right here.
Yes.
So now it's y, right?
Over.
What's it?
It will be x.
Not y, it'll be negative 1. No?
It will be negative 0. But for that you have to plug it in. But
Oh,
yeah.
So it's still negative 1, right?
Yeah, it's a negative 1.
So those will be 0 over 2.
Then you plug in 0 again. Or no? That here. First, you could distribute the negative 2 or negative 1. You get negative x approaching 0 equals negative x squared is 6x over x.
Make sure you fill in the table. I want all the stuff.
And we wanna I think you're
Yeah, me too. You are? Yeah. Kimberly, what you get?
I got 6.
Just like regular size.
Really slow?
Yeah. Yeah. That's 6 over 0.
6 over 0?
Yeah.
What did you get 0? Did y'all factor out x?
Yes. Because you know that x minus 0, and the 0 keeps in the bottom.
Then that's the 0.
Yeah, x minus 0 is just x. So, yeah, okay, you factor that out. The negative x,
Yeah.
when you plug in 0 will be 0, 0 plus 6.
You get it? Because x minus 0 is going to be 0 x. So x, you subtract 0 then x.
So we don't plug in 0 for x.
Well, it's because you're subtracting it. The equation is
confusing
x
anymore.
minus. Because the equation here feels like you use the limit, right? So x minus 4. But since the limit, you got positive or negative 6. You have to put in x minus 0. So if you subtract x from 0 from x, it'll give you x.
Yes, sir.
Yeah? Okay. And like on the other one, he left it as x minus 4 because he can't.
Okay, 1 minute left.